Tomorrow will be better. A 2 kg mass moves down a rough plane inclined at 30 degrees to the horizontal and faces a resistance of 3.45 Newton. Find its acceleration down the plane. Dear friends, I've always said that for such questions, it's always good to start with the free body diagram because a free body diagram paints a picture of what's happening and makes it look like right in front of you. With this, it becomes pretty easy to solve the question. Here is one which I've started. Follow me, dear friends. Solution. Let us represent this information on this free body diagram. We are told that there is a certain resistance of this. Now, the term here resistance implies that if our motion is downward, then this force is necessarily acting in the inverse direction. So here I have for 3.45 Newton. Now, what about the force which is moving in this way? We don't yet know it. But experiment has shown it that if this is 30 degrees here, if this inclination here is 30 degrees, then of course we have that the weight will always act vertically downward. I was just about saying experiment has shown you that the force along this plane here is mg sine of this angle here, 30 degrees. I will not include the other forces on the other plane because we are concerned here just with movement along the downward or along this plane here. So with this in mind, we will apply Newton's second law, according to which F equals ma. This is the acceleration we are looking for. But hey, this F here is neither this force nor this one here, but it is a resolution of these two forces, is a resultant of the two forces. Now we will say, but this F here is actually this force here, which is in the direction of motion. We will consider it positive, and then minus this other one because it opposes motion. So we will have that mg sine 30 degrees minus 3.45. If you correctly do this, you will have that F, the resultant force, will be equal to 6. Will be roughly equal to 6.54 Newton. Yeah, if you do it well. So with this in mind, now we will use this force and put it in this formula. So since we said F equals ma, this is what we are looking for, guys. Make A the subject. F equals ma implies that A will be equal to F on n. This F here is what we just got here. Therefore, the A we are looking for will be nothing else but this F